Well, let's continue with triple integration. And I'm going to give you two things now. One is notation. So we have the general notation for the double integration, where R is our region of integration and the dA would be a unit of area. And we know that dA can be written several ways. dy dx, dx dy, r dr d theta, if we're in polar. So volume, there are also multiple notations, but the representative notation or general notation, the region of integration is called Q, and they use a representational unit of volume. And there are multiple ways of writing the order for volume. So when you see this notation, this is the notation that's, for example, dz, dy, dx. That would be sort of a basic case. So we're going to do another volume calculation. So a solid is bounded by z equals 0 and z equals 5 minus x squared minus y squared. So z equals 0 is the xy plane. And z equals 5 minus x squared minus y squared is a paraboloid, our parabola bowl, I've called it. And that would represent the third dimension, and it opens downwards. And so let me do a sketch of that. So I draw the upside down, whoops, parabola, and put a little arc notation to sort of imply that it's a little bit three-dimensional. And there's the z-axis, the x-axis, the y-axis, and it hits the z-axis when x and y are 0. Z is its largest, it's 5. Now remember, this bowl goes down forever, but the other boundary is the xy plane. So we're looking at the solid object made by the paraboloid and the xy plane. Now, what shape is it when this paraboloid intersects with the xy plane? So if you were to let z equal 0 and substitute it here, and do a little rewrite, we would find that we have a circle. Radius square root of 5. Well, for the basic triple integral case, that's not a beautiful circle, but it's going to have to count. This would be our two-dimensional region of integration if it was a double integral. But we'll add on z equals 5 minus x squared minus y squared and z equals 0 as our third integration notation. So if I want to set up my triple integral, 1, 2, 3, dz, dy, dx, z goes from 0 to 5 minus x squared minus y squared, and that's provided with the information above. Now what about our circle? Well, if x squared plus y squared is 5, then we know that y is equal to the positive and negative square root of 5 minus x squared. Those will become our boundaries for the y part of this triple integral. Negative root 5 minus x squared and positive root 5 minus x squared. And then the x boundaries are constants. The last integration is always a constant. Root 5 is from negative root 5 to positive root 5. And there you have it. Volume of this three-dimensional solid region. Now, if looking at it makes you think thoughts that are sort of reminding you of polar coordinates, just stay tuned for some future videos. You'll see that the world of polar and the world of three dimensions do have a meeting place, but we'll find out later.